All right, video lesson number 9, problems involving the mole. Now, a couple things to keep in mind when we're solving these types of problems with dimensional analysis. Number 1, you've got 3 important, valuable tools in your toolbox. Don't forget them, and they're right behind me on this roadmap. Number 1 tool relates the mole to the number of particles. That's Avogadro's number, and it states that 1 mole is 6.02 times 10 to the 23rd particles. That could be atoms, molecules, or formula units. Now with all these tools, remember you can flip them. Just like a dollar is 4 quarters, 4 quarters is also a dollar, right? So you can flip them depending on your needs in your problem solving. Okay, tool number 2 is the molar mass, which states that 1 mole of any substance has a mass equivalent in grams as what is on the periodic table in terms of the atomic mass. So all you do for the molar mass is you got to calculate that. You're going to have to work for it a little bit, but once you get that, you're going to have grams per mole. That relates the mole to mass. That's tool number 2. Tool number 3 is the molar volume. So when we're dealing with gases or problems involving gases, 1 mole of any gas at standard temperature and pressure is 22.4 liters. So those are your 3 tools in your toolbox. Got to keep them in mind at all times. And number 2 little tip is basically what you're going to do with these problems is always start by changing the given into moles. And then once you do that, then you can convert to what you want. So let me do a couple of examples and show you. Okay, so our first example says, what is the mass of 1.806 times 10 to the 24 silver atoms? Same approach, all problems. Identify the given and unknown unit. So my given units are the silver atoms, right? Big ugly number, but that's okay because we're used to using scientific notation. And then my unknown is mass. Now it doesn't specifically say it, but my mass will always be in grams. Now this may be helpful to look at the roadmap after I set up my T-chart here. So let's go ahead and set it up. We've got 1.806 times 10 to the 24th silver atoms. Okay, and then over here I want grams. Okay, so if you notice my roadmap, this might be helpful to visualize. I've got particles. What I'm shooting for is mass. Okay, notice how to get from here to here. I can't go directly from atoms to grams. I have to go through moles. So that was my second tip. You almost always are going to start by changing the given into moles. Okay, so if I'm going to do that, silver atoms has to go on bottom, so it cancels, right? And then moles has to go on top, because that's what I want. I'm changing the given into moles. There it goes. I can cancel it right now if I want. Now, I've got moles to grams, okay? So I might recognize that that is the molar mass. That's where I am right here on my roadmap. So again, to get rid of moles of silver, I've got to put moles down there, and then grams will go on top. Notice how moles cancel, and I get grams. That's exactly what I want. Okay, so now I go back. Step 3 in our dimensional analysis is plug in the numbers. So remember, 1 mole of anything is 6.02 times 10 to the 23rd. Okay, and just like a dozen is 12, remember a mole means 6.02 times 10 to the 23rd. Okay, so that's Avogadro's number. Then I go back and plug in the molar mass here. So 1 mole is how many grams? That's what I'm going to have to look up on the periodic table. In this case, it's a little bit easy, but if it was a compound, I might have to add up the individual masses, and that would be a little bit more work. But if I look on my periodic table, silver has a mass, if I round it, of 108 grams, okay? And so now I'm ready to simplify, okay? So I would multiply, if I have my calculator, which I do, which you can't see, and unfortunately I can't do it on the smartboard, but if I did 1.806 times 10, okay, to the 24th, remember that's the exponent key, and then I just times it by 108, and then divide it by 6.02 times 10 to the 23rd, I get 324 grams. Okay, so you want to type that in on your calculator. Now, can you solve it without a calculator? A lot of times you can if you just recognize some patterns here. So this means times 10, right, 23 times, so that's 23 tens. I can cancel out 23 tens, and if I do so, that leaves me 1 10 right here, right? Can I do 1.80 times 10 in my head? Yes, that gives me 18. So basically all that up there is 18. And I forgot that 0.6, didn't I, right there? So if I divide 6.02 by 18.06, that would give me, you can see 3, and so it would just be 3 times 108, which is 324. Okay? So that was one example involving mass and atoms or particles. Let me do another one with volume here and mass. Okay? So again, how are we going to do this? Same approach, identify the given and unknown. So what's given? 64 grams. Okay? What's unknown is the volume, and it doesn't say per se what unit, but that we have to recognize will always be liters as well. That's on my roadmap, but sometimes it'll even say it in the problem. Okay, so on my map here, I've got mass. Where am I trying to get to? I'm trying to get up here to volume, recognizing that I have to go through moles once again. So set up your T-chart. The given goes on the left. So what do we have? We have 64 grams of methane, which is CH4. Okay? And what am I trying to get? I'm trying to get liters of that gas, CH4. Okay? What's step 1? Always change the given into moles. So that's going to be using tool number 2, which is the molar mass, right? Grams per mole. So I put grams on the bottom, right? So that would cancel. And then step 2 is going to be turning these moles into liters. And again, you can do that if we're at standard temperature and pressure, which we're going to assume unless it states otherwise. Okay? So now I go back and plug in my numbers. Notice here, to get the molar mass of CH4, that's going to take a little bit of work, not a ton of work, but I'm going to have to, on the side here, try to figure out, okay, carbon's got a mass of 12, right? And there's 1, so that's 12 times 1 is equal to 12. Hydrogen, so that's my carbon. Hydrogen has a mass of 1, and there's 4 of them, so that's a total of 4, so that gives me a total of what? 16. So the molar mass of methane is 16 grams per mole. Okay, so I have to kind of do that on the side. I like to do that on the bottom, and there I go. So I got to plug in that tool. Again, that's going to be specific, the molar mass based off of the substance. Okay. Now, what's not specific is the molar volume. So any gas, okay, at standard temperature pressure will always have a volume, 1 mole of it, of 22.4 liters. So you can see how that is kind of easy. Okay, it's kind of like Avogadro's number. The molar volume, these two right here, will always be the same. It's just this one in here where you're going to have to work and do a little bit of calculation. Okay, so you might recognize, well, I could do it on my calculator, of course. So again, you can't see me do it on the calculator, but 64 times 22.4 is equal to that divided by 16. I get 89.6 liters. Okay. Again, I can solve this recognizing perhaps that 16 without the calculator, I should say, goes into here 4 times. Okay, and then 4 times 22.4 is 89.6. So you can do it kind of both ways, with or without a calculator, some of them. But it's always nice to have your calculator there as a check if it's available. Okay? So hopefully that was helpful. Good luck on solving problems with the mole, and I'll see you in class.